In the previous video clip, we have defined one very important parameter which we have called modulation index. It is defined as AM by AC, where AM is the peak amplitude of the modulating signal and AC is the peak amplitude of the carrier signal. We had seen two cases. If AM is less than AC, then modulation index will be less than 1. If AM is equal to AC, then modulation index will be equal to 1. And we had seen both the waveforms. The actual AM waveform that we had drawn was drawn for AM less than 1, and the fourth waveform that you can see in this slide also is drawn for M equal to 1. So when AM and AC are both exactly same, modulation index will be equal to 1. In this case, both the envelopes will touch each other. So third case is very obvious. It will occur when AM is greater than AC, and in this case small m will take values greater than 1. Now let us try to understand what will happen if AM is greater than AC. In this third case, if you try to draw the waveforms, if you try to draw the modulated waveform, because m is greater than 1, you can see that when m was less than 1, the two envelopes were away from each other. When you start increasing m towards 1, the envelopes they start coming towards each other, they touch to each other. So it is very obvious that if m becomes greater than 1, the positive envelope will cross the x-axis and go to the negative side, and the negative envelope will cross the x-axis and go to the positive side. Your AM signal will be available between the two envelopes, but what will go wrong is the overlapping of the two envelopes. So this is a region where the two envelopes will overlap each other, and this is a region where the signal gets distorted. This generates distortion in the signal. Now why do we call it distortion in the signal? That is simply because the signal has run into something called as overmodulation. The overmodulation takes place whenever AM is greater than AC, and in that case the value of modulation index will be greater than 1. Now what is the problem if the signal is overmodulated, and why do we call it a distortion? Let us remember that when the signal is received on the receiver side, the signal has to go through a process called demodulation, which is inverse of modulation. Now it is very obvious that in the process of demodulation, the input will be the modulated signal, and out of that modulated signal we will extract the modulating signal back. Now in case of AM receiver, we use a circuitry which is going to read the peak amplitudes of the modulated signal, and if you can read the peak amplitude of the modulated signal, then you can get your original signal back, because the peak amplitudes of the modulated signal resemble exactly to the modulating signal. Such a circuit which will be used on the receiver side for the demodulation process is called envelope detector. That is simply because it will detect the envelope of the signal. An envelope of the signal looks exactly same as the modulating signal. Now to an envelope detector, if you give over-modulated signal, then how will be its output? If you give over-modulated signal to envelope detector, it will detect the positive envelope, but now my positive envelope is a little bit different. You can see the positive envelope crosses the x-axis and goes onto the negative side. The envelope detector will detect the part which is there either completely on the positive side or completely on the negative side. So in this process, the envelope detector will detect the positive envelope, but the part which is completely on the positive side. And as you can see, this does not look like my original modulating signal, and hence the simple conclusion is that when the signal is over modulated, you cannot demodulate the signal using envelope detector, and hence your demodulation will fail. Let me make one thing very clear, that it is not true that overmodulated signal cannot be demodulated at all. The conclusion we are making that overmodulated signal cannot be demodulated using envelope detector. So if I want to make envelope detector being used as demodulator, then my signal cannot be overmodulated. So in short, whenever we discuss generation of AM, we will make sure that we avoid the third case in which the signal runs into overmodulation.